Good afternoon, class. We are looking at Chapter 3, Derivatives. This is Section 3.1, Derivatives and Rates of Change. So in Chapter 3, we're going to cover derivatives and rates of change, the derivative as a function, basic differentiation formulas, the product and quotient rules, the chain rule, derivatives of the log functions and differentials, and this is a general definition. We will look at it shortly. F prime of A is the limit of f of x minus f of A over x minus A as x approaches A, or limit of f of A plus h minus f of A over h as h approaches 0. Let's remind everybody, we looked at the concept of convergence versus divergence. When you have the limit of A sub n as n approaches infinity equals L, then A sub n converges to L if the limit is infinity, negative infinity, or does not exist. The sequence diverges. And we said to find limits, we simply plug in. Here's the definition of a limit. One-sided limit, meaning the limit of f of x as x approaches A from the left and right must be identical for the limit to exist. And as you can see in all three cases here, that is the case. The limit as x approaches A in all of them is the same. And the difference is that in part A, f of A is also L. In part B, f of A is not. It's equal to something else like B. And in part C, f of A is missing. So it makes part A continuous function at A, because by definition of a continuity, the limit of f of x as x approaches A equals f of A, which is the case here, makes it a continuous function. Then we looked at definition of a VA and HA. VA stands for vertical asymptotes, have the equation x equals A. If the limit of the function as x approaches either A or A from the left or A from the right is negative or positive infinity. And the line y equals L represents a horizontal asymptote as long as the limit of f of x, whether x approaches negative or positive infinity, is L. And now the new stuff, we are going to look at the derivatives and rates of change, or tangents. If you have the function y equals f of x, and then we have one point P with coordinates A and f of A, and then we have another point Q, one way to call it would be x and f of x. Then when we connect the 2 points and we continue indefinitely on both sides, we create a line called a secant line, and we can calculate the slope of this line, which is the average rate of change, using the good old slope, rise over run. So M, the tangent for this PQ, is delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. There's nothing brand new here. Instead of y sub 2, we could say f of x. Instead of y sub 1, we could say f of A, and the bottom becomes x minus A. So this is exactly the same thing, putting it slightly different. So what you're looking at, x minus A is the run, f of x minus f of A is the rise. Now, if we keep this as A and f of A, but now this point, okay, instead of calling it x and f of x, we call this distance h, then this is A plus h, and the y coordinate for this point is f of A plus h. Please understand the y coordinate for this point is f of A, for this one is f of A plus h. Okay, in other words, over here, the rise would be f of A plus h minus f of A. So if we use that, f of A plus h minus f of A would be the numerator, And the denominator will be a plus h minus a, which is h. And if we call this point b, and therefore this is f of a b, then this equation f of x becomes f of a b, x becomes b. And what is the point? All of them are the same. Rise over run depends on how you look at it, depending on the text. You may be dealing with this, like what we did in elementary and intermediate algebra, and then a little bit more interesting in college algebra and pre-calculus. We looked at these formats, and these formats are called difference quotients. Now, if you look at the following graph, we have this secant lines, the blue ones. And as Q approaches P, the tangent line is the limiting position of the secant line PQ as Q approaches P. As we get closer and closer to P, what happens is that PQ has 2 points, we can calculate the slope. But now this line, the red line is the tangent line, has only 1 point. So the tangent line is the limiting position of a secant line. And the slope of a tangent line, also known as the instantaneous rate of change, can be found as follows. M of tangent line is the limit of M of PQ, where Q approaches P. Q is approaches P. Or you can look at this one, as X approaches A, if you look at this one. Or you can look at this one and say as H approaches 0. So this one as H approaches 0, this one as X approaches A, and they all mean the same thing. So M of a tangent line, also known as f prime at point A, we use either this formula or this formula. The limit of f of x minus f of a over x minus a as x approaches A, or the limit of f of a plus h minus f of a over h as h approaches 0. So remember, when we want to find the equation of a line, we use the standard form ax plus by equals c. We use the point slope form y minus y1 equals m times x minus x of 1. We use the slope intercept form. Ultimately, we solve for y and we get y equals mx plus b. So what we are going to do, in order to find the equation of a tangent line, we're going to start with the point slope. Now notice, by the way, this point has coordinates a and f of a, right? So y minus f of a, or y1, y minus f of a, or y1, equals m. You said f prime of a is m, x minus x of 1, x minus x of 1. So we're going to use this point and we write it in this format. Do I have to memorize that? Absolutely not. Just stick with the point slope formula that you learned from elementary algebra. It'll do the job. The difference quotient. As I mentioned, everything that we saw in the previous page is really known as a difference quotient, rise over run. Delta y over delta x, or f of x of 2 minus f of x of 1 over x of 2 minus x of 1. That's another way to approach it. Call this x of 1. So this has coordinates x of 1 and f of x of 1. Call this x of 2. This has coordinates x of 2 and f of x of 2. Now this is the rise, delta y. This is the run, delta x. So you could say, instead of x of 2, it's x of 1 plus delta x. This is called the average rate of change of y with respect to x over the interval of x of 1 to x of 2, and can be interpreted as the slope of a secant line, the blue line, PQ. Here's the derivative of f prime of x of 1, as we mentioned in the previous page. If we take this limit and we let x of 2 approach x of 1, or delta x go to 0. So take a look at this one, delta x goes to 0. Take a look at this one, x of 2 approaches x of 1. And this is from the previous page, x approaches a, and this is from the previous page, h approaches 0. All of them mean the same thing. So The derivative f prime of a is the instantaneous rate of change of y equals f of x with respect to x when x equals a, and there are two ways of approaching them, and we will look at examples doing just that. Average rate of change, m of a pq, instantaneous rate of change, m of the tangent line, f prime. So having said that, let's start with a very simple example. Find the average rate of change of f of x, which is x squared minus 3x from 2 to 4. Now, this is elementary algebra, and please understand, anytime they give us 2 points, that means the average rate. That means rise over run. That means f of b minus f of a over b minus a, or f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub. So with that being the case, we want f of 4 minus f of 2 over 4 minus 2. This is elementary algebra, everybody. So we plug in 4. We get 4 squared minus 3 times 4, minus we plug in 2. We get 2 squared minus 3 times 2. And the denominator, obviously, 4 minus 2 becomes 2. So let's figure this out. This is 16. So 16, this is 12. So 16 minus 12 is 4. This is 4 minus 6 is negative 2. So the numerator is 4 plus 2. 6 divided by 2 is 3. Elementary algebra, nothing brand new. What if we want to find the instantaneous rate of change of f of x at x equals 4? Even if they don't mention that, that means instantaneous because you have a 1 point. Class, we have 2 points here. We have only 1 point here. And that's the difference between the two. This makes it the good old slope for a line given 2 points. This one is the slope of a tangent line requiring differentiation. So we can use one of those formulas. In fact, for practice, I'm going to use both of them. So I'm going to start with this one, and a is 4. So I'm going to replace the a with 4. So f prime of 4 is the limit as h approaches 0 of 4 plus a, f of 4 plus h minus f of 4 over h. Replace the a with 4. Let's plug it into this. We get 4 plus h squared minus 3 times 4 plus h. This is algebra. By the way, many times people just evaluate this and at the end they apply the limit. So just simplify this. This is algebra class. Simplify this expression, okay? How do you do that? Plug in 4 plus h, so you get 4 plus h squared minus 3 times 4 plus h minus f of 4. Again, f of 4 is 4 squared times minus 3 times 4, or just we know it's 4. If you want to use the 4 here, I'm fine with that, or just redo it. Okay. So what do we get? Again, reminding everyone. A plus b squared, everybody remembers it's a squared plus 2ab plus b squared, and if I'm subtracting, I'm writing a minus b squared. This is the one that changes, okay? So now, this is 4 squared, which is 16, plus 2 times 4 times h, which is 8h, plus h squared. Minus 12, minus 3h. Again, I just can write 4, or just minus, this is 16, minus 12, plus 12. The reason I do that, because In fact, it becomes pretty simple. If you look at all those numbers, everybody, 16 and minus 16, negative 12 and 12, they cancel each other. 8h minus 3h, 5h. So in the numerator, we end up with 5h and h squared. We can take the h out. These two cancel each other. We get only 5 plus h. And now if you replace it, you get 5. And we are done. However, for practice, I want to use this one too, and it should give me the same answer. So I want f prime of 4, which is the limit as x approaches 4 of f of x minus f of 4 over x minus 4. And again, class, you don't have to do that. I'm just doing it for practice, making sure we are exposed to both methods. So what is f of x? X squared minus 3x. What is f of 4? Again, I don't want to go through the process. We showed it here that it's 4. So replace this one with 4. X squared minus 3x minus 4 is the numerator. If you plug in, you get 0 over 0, and x minus 4 is the problem. So we should have a factor of x minus 4. We want two numbers. The product is negative 4. The sum is negative 3. So it's minus 4 and 1. And this is what you get. I'm assuming, again, we are very comfortable with factoring. These two cancel each other. We get the limit of x plus 1 as x approaches 4. When you replace the x with 4, you get the same number that we got here, 5. And we should, so we're done. All right. We are going to move on. We want to find an equation of a tangent line with a parabola y equals x squared at the point P with coordinates 1 and 1. Please understand, if x is given, you plug in and you get the same answer. They don't have to give us both. If they give us just x is good enough. For example, if they said at x equals 5, then y equals x squared becomes 25. So it's 5 comma 25. Okay. Example. If they said at x equals 5, it means 5 comma 25. So they don't have to give us a pair. We can figure it out by putting it. All right. Notice we are going to use those formulas, and a is 1, and the function y or f of x equals x squared. Again, I'm going to do both methods for practice. So if we start with this one now, we want f prime of 1. So replace all the a's with 1. Okay, everybody, all the a's with 1. So m or f prime of 1 is the limit of f of x minus f of 1 over x minus 1 as x approaches 1. And as you know, f of x is obviously x squared. And this can be factored. By the way, if you plug in, I hope you notice you get 0 over 0, and you're dealing with a rational expression. So you factor this into x minus 1 and x plus 1, because everybody knows that a squared minus b squared is a minus b times a plus b. These two cancel each other. And now when we plug in, we get number 2. All right, so we got the slope. Y minus y1 equals m times x minus x sub 1. So y minus 1 equals m 2 times x minus x sub 1, which is 1. Just plug in elementary algebra, find the equation of a tangent line. You don't have to memorize the other formula that I showed you, or which is y minus f of a equals f prime of a times x minus a. It's the same thing. And right now you have y minus 1 equals 2x minus 2. If you move the negative one becomes positive 1, and y equals 2x minus 1 is the final answer. Now, before we move on, I want you to know that this pair x comma y belongs to the original function. Also, it's a point of tangency, so it belongs to this function as well. Now, if you plug in 1, you should get 1, and you do. And what it indicates is that this process is right. Doesn't say anything about 2. Whether 2 is right or wrong, it can't tell you that. But it can tell you whatever number that you used here with this, everything was done. Every step here is right. Here's the second method. The slope is the limit of f of a plus h minus f of a over h as h approaches 0. So I want to use that one. And obviously, I'm going to replace the a with the x coordinate, which is 1. And again, this is what matters, this fraction, which requires your algebraic techniques to do the math. So what is f of 1 plus h? 1 plus h squared. Minus, what is f of 1? You can plug it in, but you already have it. The y coordinate is f of 1, right? And again, you square this. By now, it should be a piece of cake. A squared is 1, square root of 1 plus 2 times 1 times h is 2h plus h squared, and this doesn't change. So you're squaring this piece, 1 plus h quantity squared, and you get this. So 1 cancels out the negative 1. Notice we can factor the h out from the numerator. We can drop the common factor of h, and all remains is limit of 2 plus h as h approaches 0. When you replace this 0, you get the same 2. Take a look. Both of them are the same. We were interested in finding the slope. This method or this method, they must give us the same answer. Again, you don't have to do both. For practice, we did it. Of course, you have to finish it by this. I'm not going to go over that again. I'm not going to redo this part, but I just wanted to make sure you can find the slope in 2 different ways. Here's another example. We want to find an equation of a tangent line to the graph of this function f of x squared of x at this point 16, 4. And again, notice if they told us x is 16, you plug in, you get 4. If they said x is 100, then it's 100, 10. I'm not going to bother with that, but I hope you understand just the x coordinate is good enough. So in this example, a is 16 and f of x squared of x. And I'm going to start with this one to find the slope. Therefore, I'm going to replace the a here and here. with 16. This is f prime. M is f prime of A or f prime of 16. So replace the A with 16. So what is f of 16 plus h is square root of 16 plus h. What is f of 16? We already know it's 4. But if we plug it here, we get square root of 16. Uh, let me tell you why I don't want to use 4. Because what if it wasn't a perfect square number? For example, it was 17. We would use square root of 17, right? It wouldn't come out. And I want to show you it makes no difference as far as our process is concerned. So I want to keep it that way. And now, um, if you plug in, of course, you get 0 over 0. And anybody remembers what technique we used in a case like this? Anybody remembers the name of a technique? This is an indeterminate form. And to fix this indeterminate form, we use an algebraic technique. What is that? Anybody? It's called the conjugate because we have a square root. So the conjugate of this is the same thing with the plus sign here. So we multiply and divide by it because this must be equal to 1, and it is. So the technique is called using the conjugate, multiply by the conjugate of the numerator and divide by. So first, what happens to the denominator? You keep it as a product. You never ever distribute. I've said that many times. This is important. The top, each one, this is a minus b, this is a plus b. Each one gets squared up. So we get the result for this is square root of 16 plus h squared minus square root of 16 squared. In other words, each one comes out from the radical sign. When it happens, these two cancel each other. So the numerator has nothing but h. And now the h from the top and the bottom, they can cancel each other. We end up with the 1 in the numerator only. Now, if I plug in, what do I get? Square root of 16, which is 4. Square root of 16, which is 4. I get 8 in the denominator. So 1 over 8 is the final answer for this case. We want the equation of a tangent line. Y minus y1 is m times x minus x of 1. Y minus y1, which is 4, equals m 1 over 8, x minus x of 1, which is 16. So the right side, everybody, is 1 over 8 times x minus 16 over 8, or 2. And this moves, becomes positive 4, combines with negative 2. The final answer is y equals 1 over 8x plus 2. This is the equation of a tangent line. Now, again, this pair belongs to the original function. It must satisfy it. Also, it belongs to the tangent line because it's a point of tangency and it must satisfy that. So if I put the 16 here, 1 over 8 times 16 is 2 plus 2, 4. It works. What does it mean? This process is done right. Doesn't mean that 1 over 8 is right. It just talks about this process. I want to use this one. I want to, again, find this with the second method for practice where A is 16, everybody. So I'm going to use that for practice, everybody. So we have the limit to f prime of 16. We have the limit as x approaches 16 of f of x minus f of 16 over x minus 16. So what is f of x? Square root of x. What is f of 16? 4. You have to evaluate. Again, I hope you see that you get 0 over 0. And we use the same technique, namely the conjugate. The conjugate of square root of x minus 4 is square root of x plus 4. So multiply and divide by it. Again, the denominator, don't touch it. Write it as a product. What happens to the numerator? When you multiply, each one gets squared up. So we have square root of x squared, which becomes x minus 4 squared, which becomes 16. X minus 16 cancels out x minus 16. So we have 1 over square root of x plus 4. And we want to take a limit of that expression as x approaches 16. When you plug in 16, that becomes 4 and 4, 8. And we get the same 1 over 8 that we found here. The same 1 over 8. Again, I repeat that we don't have to do both ways, okay? But we are doing it for practice to make sure we can handle it, and sometimes one may be easier than the other. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals 6x minus 1/4 x squared. How tall is the sunflower 8 weeks after planting? Over here, it mentions include proper units. Class, anytime you do word problem and anywhere you see units, your answer, if it involves units, you must answer it with units, even if they don't mention that, you should. So part A is elementary algebra. Can anybody tell us what we should do for part A? What do you think we should do? Anyone? Just plug in f of 8. So that means 6 times 8 minus 1/4 of 8 squared. This is 48 minus, this is 64. And 1/4 of that is 16. And that gives us 32, the units. Height in inches, 32 inches. That would be the height. Find the average rate of growth from the end of week 6 to the end of week 12. Please understand, Because we have 2 points in time, even if they don't mention average, if they said find the rate of growth, since there are 2 points, that means rise over run. Delta y over delta x equals f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, or f of 12 minus f of 6 over 12 minus. That's all it means. So we're going to put 12 in here, minus we're going to put 6 in here. So 6 times 12 minus 1/4 times 12 squared, minus the brackets f of 6. 6 times 6 and then 1/4 of 6 squared. We're going to simplify this. This is 72. This is 144, and 1/4 of it is 36. This is 36 minus 6 squared is 36, and 1/4 of it is 9. Okay, and so we have minus 36 minus 9 is 27. This is the numerator, 72 minus 36 minus 27. Everything in the numerator simplifies to number 9. 9 over 6, 3/2 of an inch per week. Delta y over delta x. The units come from the units of the numerator over the units of the denominator. So 3/2 of an inch per week, because the numerator represents the height, the denominator the change in height, the denominator represents the change in weeks. Okay. Find the instantaneous rate of change in 10 weeks. Now, even if they don't mention instantaneous, again, I want you to see we have 2 points here, but we have only 1 point, which means precisely that. And we're going to use one of those. For example, f prime of a, that means f prime of 10. And so using the first one, the limit of f of x minus f of 10 over x minus 10 as x approaches 10. You can try the other one, makes no difference. One is good enough. So let's evaluate this expression and simplify and take a limit. So we write f of x minus f of 10. We write 6 times 10 minus 1/4 of 10 squared. The denominator is simply x minus 10. Now, this numerator has to be simplified. That means, and then of course the fraction, that means it's all your algebraic techniques. It has got nothing to do with the limit. Simplify this and take a limit. This is 60 minus 10 squared, everybody knows, is 100. 1/4 of it is 25. So 60 minus 25 is 35. Everything here is replaced with 35. Because this is 1/4 and it's a fraction, you're really dealing with a complex fraction. Let's multiply the top and the bottom by 4. When we do that, this becomes 24x. This 1/4 goes away, becomes minus x squared. And this one, minus 35 times 4 becomes minus 140. And the denominator you just write as a product. Since we want to factor this, we are going to put it in descending order. So we're going to write this guy first. And since we want to factor the numerator, we're going to take the negative out because we want the coefficient to be positive for the sake of factoring. So when you take the negative out, this becomes x squared, this becomes minus 24x, this becomes plus 140. I hope you see it's all algebra. Now, we want to factor this. We want two numbers. The product is 140. The sum is negative 24. And by the way, because it's positive and this is negative, both of them are negative. But notice the problem is x minus 10 making the denominator 0, right? If you plug in, you get 0 over 0, right? If you plug in, you get 0 over 0 class. And it is the 0 in the denominator, which is a problem. So if this has x minus 10, this must have x minus 10. That's another way of thinking about it. So it's x minus 10 times x minus 14. What about the negative sign? You can keep it here or take it outside the limit. It makes no difference. The limit pertains to x. And now x minus 10 cancel each other. This is what we have. Again, notice everything is algebra. Now, if I put the 10 here, 10 minus 14 is negative 4. Negative 4 divided by 4 is negative 1. With this negative becomes positive 1. And the units are inches per week. Just as delta y over delta x, the same thing here, because this is class dy dx. The change in y over change in x on the average, the change in y over change in x instantaneous, 1 inch per week. So they have the same units. Now, notice this, everybody. This is algebra. This is algebra. This is algebra. This is algebra. It's really at the end that we apply the limit, and that becomes the calculus. Explain the meaning of your answer to part C. On week 10 or after week 10, the sunflower is growing at a rate of 1 inch per week. At that moment, that's the meaning of instantaneous rate of change. The distance in feet of an object from a starting point is given as s of t equals 2t squared minus 5t plus 4, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? This, again, 2 pieces of time, that means average, that means this, okay? And it's exactly like saying that if I cover, I don't know, 80 miles over the course of 2 hours, what is my average speed? 80 divided by 2 is 40 miles per hour. And that's an average speed. That doesn't mean at any given time that was my speed. On the average, I did that. So using that, we are going to go with S of 4 minus S of 2 over 4 minus 2. So S of 4 minus S of 2 over 4 minus 2. So now plug in 4. That means 2 times 4 squared minus 5 times 4 plus 4. So evaluate the function at 4. Minus S of 2, plug in 2. Evaluate the function at 2. 2 times 2 squared minus 5 times 2 plus 40. The bottom is simply 2. So this is S of 4. This is S of 2. And 4 squared is 16. 2 times that is 32. Minus 20 plus 40. Thirty-two minus 20, 12, and 40 is 52. 2 squared is 4. So we have 8 minus 10 plus 40. So that makes it 38. So we have 52 minus 38 in the numerator, which is 14 over 2 or 7 feet per second. Again, as far as the units, everybody, units of the numerator over the units of the denominator. The numerator is about distance, the denominator is about time. So feet per second. Units follow the formulas. The next part, we want to find the instantaneous velocity of the object at 4 seconds. Again, notice here we have 2 points in time. Now we have only 1 point in time, which means instantaneous velocity. And notice instead of f function, we have the s function, okay? So big deal. So we use that formula where a is 4, okay, everybody? So let's take a limit, and a is replaced with 4. So s of 4 plus h minus s of 4 over h. So again, just look at this one, simplify this fraction, and when you're done, take a limit. That's really the bottom line, which is a few algebraic steps. So what is s of 4 plus h? 2 times 4 plus h squared minus 5 times 4 plus h plus 40 minus s of 4. I can calculate it, or I've done it here. It was 52. So plug in. So this 52 class, s of 4, I just used it. I used the 52 that we calculated, okay? Now 2 times 4 plus h squared minus 5 times 4 plus h plus 40. We're going to simplify this. To do so, again, a plus b squared. So this is 16 plus 2 times 4 times 8, h, 8h plus h squared. So I hope everybody knows this is equal to that. So I'm going to multiply by 2. I get 2 times 16, which is 32, plus 16h plus 2h squared minus 20 minus 5h. Write the rest of it. So write the 40, write the 52. Okay. Now let's combine the numbers, everybody. Here's the numbers. 32 minus 20 plus 50 minus 52. I hope you see they add up to 0. All the numbers, they add up to 0. (16h) and minus 5h, they give us 11h. So the numerator has nothing but 11h plus 2h squared. That's all. Those two. And those two, I can take the h out, factor the h out. When I do that, I can drop this h with this h. I get the limit of 2h plus 11 as h approaches 0. And when I replace it, I get 11 feet per second. Again, this class, this is ds dt. This one, delta s, delta t, they have the same units, okay? The units of the numerator over the units of the denominator. This is the average change, this is the instantaneous change. That's why feet per second in both cases. Suppose that the ball is dropped from the upper observation deck of the CN tower 450 meters above the ground, where S equals f of t equals 4.9 t squared. What is the velocity of the ball after 5 seconds? How fast is the ball traveling when it hits the ground? Well, here's the v of the instantaneous class, and we are going to use that or with the f function, because this is called f. Now, for part A, I should replace the a with 5. Go through the process of limit and find it. For part B, first I have to figure out what is the time, and there is a way I'll show you later on. After I figure out the time, then I have to go through the same process and replace the a with this new time. So that looks like redundant. That's a lot of work. Instead of changing the a to 5, I'm not going to change it. I'm going to keep it as a. In fact, we are moving towards the next section where we look at f prime of x, and we keep it as x. So it generalizes. It's a differentiation formula in general. When you fix it at a, that's the concept known as the slope of a tangent line. So if you keep it at a, the finished job will be a function of a. So for this one, you replace the a with 5. For this one, you replace the a with whatever time units here. So take a look. F of a plus h, 4.9 times a plus h squared minus f of a, 4.9 a squared. So we keep it as a. Can even keep it as t and work on it. So v of t and keep it as t. Now, what is a plus h squared? You know that to be a squared plus 2h plus h squared. You know that. And if you take the 4.9 out, again, this gives you that. If you take the 4.9 out, you can see that minus 4.9 a squared is here. And the reason we are taking 4.9 out, because now the factoring will give us a chance to get rid of a squared and negative a squared. So in the numerator, we have 4.9 times 2ah plus h squared. And we notice this has h, this has h squared. We can take the h out. If I take the h out, this is 2a, this is h. When I do that, I can drop the h. Remember, h is approaching 0, and that is the problem in the denominator. And now we have this 4.9 times 2a plus h. Take a limit as h approaches 0. Now, if I replace the h with 0, I get 2a times 4.9 or 9.8a. What does it mean? Regardless of the time a, the instantaneous velocity at time a will always be 9.8 times time a. So in this case would be 9.8 times 5, which gives us 49 meters per second. Okay, everybody? So what about this case? First, we have to figure out how long does it take for the ball to hit the ground. If the formula f of t or s is 4.9 t squared, it has to cover 450 meters, set it equal to 450. So if it covers 450, you divide by 4.9, it gives you t squared. You use a calculator. T is plus minus the square root of 91.837, and we just keep the positive one. Please understand this has two answers, positive as well as negative. We just keep the positive for the sake of time. And therefore, this formula that says 9.8 times A, which A is the general time, 9.8 times 9.6 for part B is the answer, which is 94.08 meters per second.